Hey, hi, and hello. In this video, I'm going to show you this effect of these fake planes inside of geometry that change direction towards a specific point. And you can see they are also changing size based on where that point is. And you can change coloring, and I'll show you some of these things. Here is our material. You can change the end size, brightness, the color Fresnel, that's just normal stuff. Size by distance is how far it needs to be. And the fade, what's basically the range where it will start growing or getting smaller. This controls how many have a different color, a percentage per se. The brightness, size, I mentioned that. You can also change the offset of where that fake plane is. And finally, you can have more index of refraction or less, obviously. So let's just jump into it. This is our lovely shader. Let me start by showing you this part. This is good. This part is how the intersection between the view direction and that fake plane happens. It's a custom function. I'm going to show you the code in a bit. What I'm doing here is I'm getting the offset parameter, multiplying it by a small number just to make it easier to deal with, and then transforming from object space to absolute word space and providing that to the custom function. We have the look position, which is a parameter, and this look position, I'm not exposing it because the script here, not this one, this one. So this script is just setting the look position, which is that parameter, to the direction object dot position, which is this guy. So going back here, this is what that is, and just giving it here. The starting point is basically the point where the view direction is intersecting with the actual geometry. So it's basically the position. And the direction is the view direction, which is the ray that goes from camera to that specific pixel, normalized, passed into this refract custom function, which is just an inline that calls the refract function, pass in view, normal, and IOR. You can see the types here. So we're just passing the view direction, the normal of the geometry, and the index of refraction. And that is our direction. Now, this custom code or custom node is calculating where is the intersection point between the view direction and that fake plane that we are talking about. To begin with, we are calculating the normal of that plane by subtracting the look position or subtracting plane point. Plane point is what defines where is that plane center, minus the looking position, that's our normal, or the normal of that fake plane. The distance to plane, that's the subtraction of plane point, where the center of the plane is, from the starting point, which is the geometry intersection point, and the dot production between that and the plane normal, divided by the dot production of the direction, basically the camera direction to the geometry with the plane of the normal again. So that gives us the distance between like the position of that pixel of the geometry, the position from that to the center of the fake plane, right? Now that if we multiply it by the direction and add it to the starting point, we are gonna get the intersection point with that fake plane. After that, I'm just subtracting the plane point from that so that we can have the offset. Basically, we can move where the center of that plane is. And then after that, to actually show a texture properly on that plane, we have to do tangent or get the tangent and bitangent of that plane. And I'm honestly, I honestly don't understand this code that much. But I used AI to help me with that. If you don't do this step, it's going to be stretched. So you will have to get the tangent and bitangent, which is this guy and this guy, using these calculations, and then do a dot product between the intersection point and the tangent, the intersection point and the bitangent, and you will get the x and y of the UV to be able to then just use that as the UV to sample a texture on that fake plane, right? The other things are this part is where we do the changing of the size based on how far the object is. So this is the object that we are looking at. We get the distance from the geometry, the actual object showing the plane, from the thing that we want to look at. The distance is the input of a smooth step. And then we have size by distance parameter as the edge 1. We add the fade parameter to that and use that as the edge 2. And then we multiply that by a somewhat big number. You can try different values here. So that then we add that to the end result size. So basically this value is going to be, or actually this value is going to be 0 for the for bigger distances, and it's going to be 1 for smaller distances. So then we multiply it by a larger number, we add it to the size, which is going to go into the tiling, which makes the texture much smaller. And we have an offset of 0.5 so that the scaling happens in the center of the texture. Here I'm adding a clamp wrap so that it doesn't repeat the texture. I added a small value for LOD. I think it looks better, but you can try with other stuff. Now, I experimented with two things. You can either use a replace color, you put in the color, the main color that you see in your image, put a second color, you play with the range and fuzziness, and then both goes into a lerp. And what differentiates between them is I'm using the position of the geometry as the seed for a random range, goes between 0 and 1, and that goes into a step function, and your chance parameter goes as the edge, and that's your t, right? The other thing that I experimented with is you can just plug that into a hue node. The offset is our random range value, and you have to put normalized so that it's between 0 and 1. And then we can use that here. And also what I'm doing here is just getting the alpha from the image and showing the color parameter instead, if the alpha is 1, which is or 0, which is transparent. Just multiplying it by brightness, and I'm using emission. Up here, just doing some Fresnel for the base color. Don't need to do that, and you can add whatever you want. Let's save that and show you what happens when we change to the hue. This is going to be our result. Each one will have a slightly different hue of that color, and I think all of them look pretty good. So yeah, that's it for this tutorial. Thank you so much for watching. Make sure to check the links that are in the description if you want to support me. Also, the like button, I heard it's free, so you can click that. also that subscribe button. So thank you for watching, and have a nice one.